So far we have learned many methods of solving systems of equations. What was our first method? Graphing method. Good. Second method was? Yeah, substitution. Now we're going to learn this third method called addition method. I think you might like this one because this one's kind of nice. So to solve systems of equations, well, we're going to talk about linear equations. We have this method called addition method. What is it? Well, it's this. When solving a systems of two equations, you can sometimes add the equations to obtain a new equation with just one variable. It says sometimes. Actually, it turns out you could do this every time. But we'll get there in a minute. So, and of course, this method is called addition method. Go ahead and write this down. I'll give you some time. So I actually want to get rid of this sometimes. So you could actually do this every time. Well, okay. Anyway, if you wanted to. So first, we write two equations in standard form. That's what we do. Okay. Remember standard form this way. So ax plus by equals to c, and a, b, c are integers. Okay. And you want to write them vertically. Okay. You want to write these standard equation vertically. You'll see when I do an example, it'll make sense what I mean by that. Second step after you do this is, just like the name suggests, you want to add them. Okay. You must obtain a third equation with just one variable by adding the equations. Then solve for one of the variable. Because once you add them, you have to get rid of one of the variable. Right? Then now you have one variable to solve, right? Does that make sense? Kind of like that substitution method, right? After you substitute it in, how many variables does that equation have then? Just one, right? And once you solve for that variable, you have one of the coordinate. How do we then solve for the other one? Let's say you solve for x. What do you do? So let's say the y cancels out, and you got x equals something. And what do you do with that x? You plug it in. You find the other variable. How do you do this? You plug it in to one of the original equation. And then lastly, you check the answer using both original equations. Okay, so right now, it may not make sense a lot. When we do an example, it will make sense. So let me give you, write this down for now, and then let's do an example in a minute. Go ahead and write it down. So look at example 1. I have a system of a linear equation. I wrote them vertically. Step 1 says write them in standard form. Well, I'm lucky. Why? They're both already in standard form, aren't they? So I got x plus y equals 14. X minus y equals 4. Luckily, we have both of them in standard form. If they weren't in standard form, guess what? You just rewrite them in standard form. Not a big deal. And now we're going to add them because it's addition method. Look what happens as we add them. Do we get rid of, will one of the variable go away? Yes. Look, what's x plus x, guys? 2x. What's positive y plus negative y? 0. So you see a y cancels out. That's great. So then that's what we could, and then 14 plus 4, of course, is 18. And do we know how to find x? Divide both sides by 2, we get 9. Easy? Then, so step 1, remember I told you step 1 you have to have it in standard form, write vertically. We did that. And then step 2, must obtain one new equation. Did we get one new equation just with one variable? Yeah, 2x plus 18, that's one new equation with only one variable. We know how to solve this. And we need to then solve for y, don't we? Because we know that the solution must be an ordered pair, not just one x coordinate. So how do I find y? Yeah, nice. Yeah, you plug in x into one of the equation. I like how you said one of the equation, because it really doesn't matter which equation you plug in.
Yeah, couldn't you plug it into both and you get the same answer for both? You use that.
Yeah, but that's too much work. You just use one of the thing. Because why? We're looking for a solution that is going to be true for both of them. So you could, and then when you check, yes, you plug into both. When you check, you plug into both. Now when you're solving for y, you don't need to do it both times. You know, it's too much work. So which one would you like to plug in, Anais? First one or the second one? First one? I chose the first one too. Doesn't matter, right? Because it's solution for both. Yeah. So when I solve for x, plug in, of course, x equals to 9. Y becomes, subtract 9 from both sides, I get y equals to what? 5. So what's our order pair? 9, 5. And of course, when you have time, You must check with both equations, just like substitution method. Both, I should say, both original, right? Don't both original equation. Right? Because you want to. What if you made a mistake? When you're changing. So you want to check into both original equations, right? Just it's very similar to the substitution method, right? It just makes it a lot easier, I think. Does that make sense? Questions? Easy enough?
Yes.
So basically, that's how. So why not do this every time? Kobe.
What if you add both the equations, but one of the variables don't?
That's right. What if you add them? So that's exactly what I'm trying to say. Because you have to be able to eliminate one of the variable. What if you get something like? So write this down. Why not do this? Well, because you have to be able to eliminate one of the variable. If it doesn't, that third equation, if the third equation contains both variables, then it doesn't do you any good. Does that make sense? So what if you have this situation? What are you going to do? Oh, some of you have an idea. Hold on. Okay. Good. So write this down. May I move on? Okay, you're still writing. Wait. So what if I give you an equation that looks something like this? 3x plus 2y equals to 2. 3x plus y equals to 7. Well, in this case, if you were to add them, does one of the variable go away? No, I don't have that. So that third equation would not have just one variable, it would have two. That doesn't help me much. What do I do then in this case? And I do want to use addition method. Aaron, you have any? Oh, you want to use what? Oh, what? Oh, use subtract. Well, I don't like subtraction method. So your book does give you a subtraction method. They say subtract. Don't do that. You're gonna mess up. Okay. So what can I do, Anais?
You can multiply the y equation by -1.
Exactly. Oh, we could do that. Could we multiply an equation by -1 to both sides? Is that okay? Is that something we could do? Yes. Remember, multiplication property equality says you can multiply a number, right? Same number to both sides of an equation, then they will still be equivalent, right? Does that make sense? So let's do that. Now, when you do this, nice thing happens. Shirak, what do I get when I do this?
You get negative 3x minus y equals -7.
Yeah, and we like this, don't we? Okay, by the way, first equation stays the same, doesn't it? So I have the first equation, and yes, just like you said, it becomes this. Why is this nice? Ellie, why is this nice now? Yeah, in other words, when I add them together, what happens to one of the variable? It goes away, doesn't it? And isn't that what we wanted to do? And because we can multiply the bottom one by -1, you get this. Okay? Y equals to -5. Isn't that right? Once we know the y, could we figure out what x is? Yeah, go ahead, everybody, finish it up. Give it time. Which equation should we plug into? Does it matter? No, I think I chose the first one. Or is this the first one or the second one? Oh, second one, I chose the second one. Let me plug in y in here, -5. Did you all get x equals to 4? Okay, how many people wrote down -5 comma 4? Raise your hand. None of you? Isn't it -5, 4? Oh, you mean I have to be careful when I write the answer? Oh, I have to write 4 -5? Good, right? It's in what order are these order pair in? Alphabetical order, right? It's like on your homework, when they give you letters like A, B, which order do you write in? A and B, right? Alphabetical order, okay. Some of you are asking that question. Okay, you gotta write them in alphabetical order. That's why they're called order pairs. Any question? Is this okay? So that's great, but what if I give you something like this? 6x plus y equals to 6, 3x plus 2y equals to 9. I can multiply the top one or the bottom one by -1. It doesn't really help me much, does it? What am I going to do here on this one? Anybody have an idea? Oh, a lot of you. Kristen, what do you think I should do?
Multiply the bottom by -1.
Oh, if I can multiply by -1, is it okay if I multiply by another number other than -1? In this case, what happens if I multiply the bottom one by -3? The x's will cancel out, wouldn't it? So that will work. I mean -2, I'm sorry. -2, then the x's will cancel out. What about, is that the only way to do it? Owen, what's another way of doing this? Yeah, you can multiply the first equation by -2 also, okay? Right? You don't always have to multiply something by a second equation. It could be first or second. Yeah, so there are two ways. I actually did it in both ways. Which way would you like better? -2 on the bottom or -2 on the top? Doesn't matter. Okay, how about half of you on the left do it to the bottom part? You guys on the right side, why don't you try the -2 on the top part? Let's see whether we get the same answer at the end. You know what I'm talking about? So you guys on the right, multiply both sides by -2 on the top, the first equation. You guys on the left, multiply by -2 on the second equation. Because if you do it this way, you're going to get one of the variables, right? You can eliminate one of the variables. Go ahead, everybody try. I'll give you time. Let's see if we get the same answers. But I think you guys, most of you got this. By the way, if I multiply something to the left side, guess what? You must multiply the same number to the right side. It's an equation. Remember multiplication property of equality? Oh, sorry. So therefore, let me do this one first. Okay, then when I multiply the negative to the negative, bottom equation. So what do I get? Who could tell me? How about Sophia? Tell me what to write.
It becomes -6x minus 4y equals -.
Good. You have to distribute this -2, don't you? So don't you get this, class? The first equation stays the same. We haven't done anything to that first equation. Second equation becomes -6x plus -4y equals to -18. When I add them together, what is positive y plus -4y, class? -3y equals to, what's 6 plus 18? -18. -12. Y becomes 4. Any question? Those of you that multiply both sides by -2 on this side right here. Kyle, what did you get? When you do this, what do you get on the numerator? The first equation. Say it again. 1/3. Did you all get 1/3? Because you get -12x plus -2y equals to -12. And then the second equation stays the same. So you get a -9x equals to -3, right? So you get 1/3. Is that right?
Yes.
Now, for those of you that got y or those of you that get that x, you could always find the other variable by plugging it in. And when you do, did you all get positive 1/3 over 4? How many of you got 1/3 over 4? 1/3 comma 4. Not over 4. 1/3 comma 4. Yes? Any question? If you didn't, do you understand your mistake? Do you see your mistake there? Yes? Do you guys understand?
Yes.
Pretty straightforward, isn't it?
Yeah.
May I move on to the next example? Anybody need more time? Any question? Alright, let's look at the next example. Here's your next example. 4x minus 5y equals to 3. 3x plus 2y equals to -15. Uh-oh, this one looks different than the other one. Okay. What do I do? How is this one different than example 3, the previous one? Could you multiply one number to either top equation or the bottom equation to get rid of one of the variables? Not quite. Uh-oh. So what do we do in this case? 2 people see it? 3? 4? Emily, what do you think?
Multiply both equations.
Oh, could we do that? Could we multiply both equations by something? Yes, it's okay. You don't have to multiply just one. Talene, what would you do?
Multiply the top by 3,
Uh-huh.
and then the bottom.
Top equation by 3 and bottom one by?
Bottom one by
-4. If you do 4, then you gotta multiply by -1 again. So why not just do it in one step? Yes. Yeah, that would get rid of the x. Is there a way to get rid of the y?
Yeah.
How would you do this, Andrew?
You would multiply the top one by 2 and the bottom one by 5.
Yeah. Top one by 2 and bottom one by 5. Wouldn't that work? That would get rid of the y. What does this kind of like? It's kind of like, yeah.
Kind of reminds me of like world coffee.
Yeah, it's like common denominator. When you have fraction, if you have 4 and 3 as your denominator, right? Wouldn't 12 be your common denominator? If you have 5 or 2 as your denominator, wouldn't, right? So yeah, you're right. It's basically finding the, not LCD, but LCM, least common multiple. Okay, does that make sense? Anyway, so yeah, you could either do it this way or this way. Which one do you like better?
Which half of it?
It doesn't matter. Let's do this half on the left. You guys do the multiplying by 2 and 5. You guys on the right side, why don't you do 3 and -4? Okay, go ahead. Let's see. We should get the same answer, right? No matter how you do it. Okay, go ahead. Everybody try. Okay, so you guys from the right side over here, tell me what to do. When I multiply this, how about, who could tell me what to write here? How about, who have I called? Caroline, can you tell me what to write? When I multiply top 1 by 3, bottom 1 by -4.
12x minus 15y equals 9.
Good.
And then negative 12x minus 8y equals 16.
Correct. So isn't this nice? Look, we have the same x's, well, not same, they're totally opposite, right? So when I add them together, what happens to the x? They cancel out. So what do I get here? Yes, Maddie? Correct. Then you divide both sides by negative 23. You get x equals y equals to negative 3. Very good. Okay, you guys on the right side. When you try the other way, what do you get? Anybody F? What do you think? Tell me what's right.
I got 8x. No, I got 8x minus 10y equals 6 and 15x plus 10y equals 74.
Correct. Minus 74. Right? Minus 74.
minus
Yeah, when you add them together, look, the y's will cancel out, right? So, Sarah, what do I get? The y's will cancel out. What's 8x plus 15x? 23x equals to? Negative. Yeah, and then when you divide both sides by 23, you get negative 3. Right? So now, so you just have to now plug in y equals to negative 3, and then well, you guys on the right, I mean left, plug in x equals to negative 3. What did you get when you plug in? Yeah. Nope. Yeah. Negative 3 is correct. When you plug it in, did you use parentheses? Okay, please use parentheses. Some of you messed up. And you get, you should have known that on the right side. You know, you got x equals negative 3. So there you go. Any question? How many people got negative 3 as your answer? If you didn't, do you see your mistake? Okay. Any question? Is this pretty straightforward? Can you do something like this for your homework tonight? Okay. Well, let's try the last one here. This one. What if they give you fractional coefficient? What are you gonna do? It's not that bad though. It turns out, whenever you have an equation with fractions, there's an easy way to get rid of them. Yeah. All you have to do is, if you have 3x over 2 plus y equals to 6, and x plus y equals to 5, what are you going to do, first of all, with your first equation? Sophia? Yeah, multiply by 2. Multiply both sides by the LCD, remember? Whenever you have fractions in the equation, multiply both sides by the LCD, right? Least common denominator. A multiple, I guess, denominator. Then you get simply 3x plus 2y equals to 12. X plus y equals to 5. And now, all you have to do is, Anais, what would you do?
Times the bottom by -3.
Yeah, you can multiply the bottom one by negative 3, or you can multiply the bottom one by negative 2. Lara, which one would you like to do? Negative 3? Let's see. It doesn't matter, I did it both ways. Okay, go ahead, everybody finish it up. Yeah, it doesn't matter. One of them will get rid of the x, the other will get rid of the y. Does not matter. This time you get to choose whichever method you want to do. So you could either multiply by negative 2 or negative 3. Go ahead, everybody finish it up. Okay, so those of you that try by multiplying by negative 2, did you all get x equals to 2? Those of you that tried with negative 3, did you all get 3? And you, of course, plug this into any one of your original equation. You all should have gotten negative 2 comma, positive 2 comma 3. How many people got 2, 3? Okay, most of you. Any question? This easy? Hard? Can you do this for your homework tonight? Good.